Welcome to this Docker all-hands session about best practices for production-ready .NET Docker images. What I want to show you today is the different steps, the different aspects that you need to consider when you want to bring your .NET applications into Docker images so you can run them as containerized workloads. If you have been working in that space for a longer time and you have followed the various information sources from Microsoft, from Docker, from the various community bloggers that are out there, then I probably won't be able to show you a lot of new things, but I guess it still would be an interesting recap. And if you recently started with .NET in the connection with Docker and containers, then I hope that I can provide a shortcut or a fast path into getting really production-ready Docker images, looking at the size, looking at security, the attack surface, vulnerabilities, and so on. But first of all, let me introduce myself. My name is Tobias Fenster. I'm a managing partner at 4PS in Germany, which is part of the international 4PS group. We create a cloud-based ERP system for the construction industry. On the community side, I'm a Docker captain since very recently, and I'm of course very happy about that. I'm also a Portainer and Traffic ambassador, and I'm also in the Microsoft community programs for which I am an MVP, both for business applications and for Azure, and a Microsoft regional director. If you find interesting what I'm sharing today, if you want to follow along or you want to have a conversation, a discussion about containerization, Docker, .NET, technology in general, you can find my social handles here. You can find the URL to my blog, and there you can also find my podcast. But without further introduction, let's dive right into our topic, which is the demo scenario. So what are we going to take today? What are we going to put into our container image? What I did is I already created a new project and creatively called it project. And I used .NET New Web API as a command to set up that project. If you don't know, .NET New Web API is using the standard template of .NET to create, as the name says, a web API. What we want to do now is we want to put this into a Docker image, and then we want to step-by-step optimize that container image until it is production ready. And of course, we also want to take a look at the security vulnerabilities that might be in that image. We want to find them and we want to fix them. So let's take a look at the actual source code. For that, I will open Visual Studio Code. You can see here the standard template as it comes, as I said, out of the box for a web API. I only did a couple of small tweaks to make it work easier with Visual Studio Code. To show you what it does, I'll just hit F5, which builds and starts the application with the debugger attached. And then we can see that it opens up this Swagger UI website. We have one endpoint, which is the weather forecast. And if we call it, then we can see that it just returns random weather data for current dates and dates in the future. I'll already copy that URL, put it in here, so you can see this is what we want to get from our container. This is what our .NET application is supposed to return. Let's quickly stop the debugger just to show you, and now of course nothing is returned. Okay, so now we have our application and we want to put it into a Docker image. As you probably know, if you want to do that, we need to have a Dockerfile, which is kind of like the recipe or the build instructions for our Docker image. As a first step, for every Docker image, you need a base image in the from statement. And there we take it from Microsoft. We are using .NET. We want to build it, so we use the SDK and we use the latest and greatest. As we've seen, it runs on port 5000, so let's expose that port. And then we want to let .NET or ASP.NET Core know that we want to listen on that particular port. We don't care about the IP address, but it will be port 5000. Okay, now let's bring in our actual code. For this, we will create a path called source. And then we copy in all our sources, like this. We run a .NET restore for our project, which is loading the dependencies. Then we do a .NET publish, again for our project. We want to make it release ready. and we want to put it into a folder. Let's call it app/publish. And then we change into that particular folder where we just published the application, and then we run .NET. We expect a project.dll file to be generated. So yeah, that's basically it. Again, just the basic steps. If you do this in real life, then probably you will use one of the many tools that are now out there to generate those Docker files, take a look at your application, already bring in some best practices. But to really understand what we're doing, I'm doing this now really step by step manually to make sure that you can understand and follow along. And we will also take a look at the impact that the different optimizations will have. So let's change into a terminal here, do a Docker build. We'll call it my image, and the first one will have tag 001. You can see here that I've run this before, so it has a lot of cached results, but yeah, doesn't matter. This is what our build ends up with. Now let's also do a Docker run. We want to expose port 5000. We want to run it interactively. We want to immediately remove it when we're done, and we use the image that we've just now created. It's starting, it should be ready. And if we now go into the browser again and refresh, you can see that we're now getting new data, this time of course served by our container. As we're now in production mode, just to also show you this, we don't have a Swagger UI available anymore. One of the examples how you can configure a .NET application, and we will take a look later into how we can make that work. Now let's also take a look at the image size. You can see here in Docker Desktop that we are more than 800 megabytes. And of course, for a little applications that just returns random data, that's quite a bit, to put it politely. And of course, this is an aspect that we absolutely can optimize. As I said, we also want to do a Docker scan for our image. Now this is looking for vulnerabilities, and it's always a good idea to run this either even as part of your CI/CD pipeline, so that you can always find out when you have vulnerabilities and maybe react differently. As we will see in a second, there are different levels of severity for those vulnerabilities, and you could maybe decide that some of those levels you can accept, while a critical vulnerability, for example, would block the release. Now we can see we have 60 issues here. We have some with high severity, we have some with medium severity, and we have a lot with low severity. So yeah, this is obviously not ideal, but as I said, we've also already seen that the size is not ideal. So let's go back into our presentation and figure out what our first step is. And that of course is looking at the base image, because that is a huge part of what determines the size of our image. For building our application, the Microsoft.NET SDK actually is absolutely the right one. It contains the .NET CLI, the .NET runtime, and the ASP.NET Core runtime, so we can build our applications, but we should never use latest. As you've seen, I put in latest in the image, and that has worked because I've targeted .NET 7 with my application, and latest coincidentally also is 7. But if I would have run that a couple of weeks ago, then it would still have been 6.0. In the future, it might be 8.0 or whatever comes next. And yeah, then my build will break. So you should always be explicit, at least with the major and probably the minor version of your base image. And it even might happen that you have to specify exactly the version, for example 6 or 8, if you have a dependency on that specific version. And if we're thinking about the size of our image, then we should also switch to Alpine-based images instead of the current one that's Debian-based, as we've seen. That will help with the download speed, also the startup speed, and it will drastically lower the attack surface because it comes with a lot less pre-installed. Now, if you need some of the libraries of the applications that are pre-installed in the Debian image, you might have to install them in Alpine again, if possible. But if you take a look at optimizing the size and minimizing the attack surface, it's definitely Alpine as a better starting point. Let's take a look. How can we make that change? That is relatively easy. We change from latest 270 Alpine. We stop the previous container, we build the next one, give it a new version, and with that we can immediately also run it. Take a look at the functionality. Yes, it's still working. Take a look at the, oh no, not 001 but 002. Take a look at the vulnerabilities, and while this happens, let's also take a look at the size. And now you can see that we have at least reduced the size from 808 to 670 megabytes. So at least we have made some progress on the size. And if we wait for the result here, we should also see, yes, now we only have one more issue. Still there is an issue, it's low severity. I can take a look at what the actual issue is by just clicking on that link, and then I will get the information, and we will see later how we can actually fix that. We can see here that is based on this particular library and that we need to update it to a later version, and then we have the fix, and we will see in a second how that works. But for now we are happy that we have a lot smaller image, and we have a lot less vulnerabilities already. Let's go back into our presentation. Sorry, that is here. So next step that we want to take a look at is how we can better structure our image. The first thing we want to do is that we want to just copy in the CS project file and then run the restore. Because as we've seen, there's a caching mechanism for images. And as long as we don't change the CS project file, which typically is not happening that often, we can reuse the cache if there are just code changes. Now that means if we only change the code, which typically is the change that you do in a development project, then the base image and the restore of the libraries can stay in place without taking up additional time. What we also want is that we optimize the publish. We do that with a no restore because we have a dedicated step for the restore, so no need to do the restore again on the publish. And we want to do a couple of optimizations that the .NET compiler offers, which is to publish it in a trimmed way, ready to run and as a single file. That especially the ready to run doesn't have a huge impact for our demo application because it is so small and trivial, but overall this is best practices to do. And the last, and that's kind of the biggest step from a structural standpoint, is that we want to use multi-stage images. What does that mean? Now Microsoft is providing, as we've seen, the SDK for building the application, but we also have dedicated images just for running the application. For example, we have, as you can see here, the .NET Runtime image, which is available for the .NET Runtime. We have the .NET ASP.NET image, which contains the ASP.NET Core Runtime. And if we publish our application as a self-contained executable, which we will do, then we can also use the runtime dependencies, which only contains the necessary dependencies for our application. And that, as we will see, will even bring down the size of the resulting image. So let's go back into our code. And what we will do, as I said, is we want to create a multi-stage environment. So we give the first stage a name. We call it build because this is where we want to do the build. And then we copy in part of the building instructions. But as I said, as a first step, we're not copying in everything, but instead we're just copying in the project.cs project file, and we bring it into our source folder. And then we do the .NET restore. As we later want to run the publish ready to run, we also need to provide the runtime, which is Alpine x64 in my case, and we need to let it know that we want to publish ready to run equals true. So this makes sure that the restore is done in the right way so that we can later run the optimized publish. Now we have restored the dependencies and we can copy in our sources. And then of course we want to do the .NET publish. And this is a duplicate now, so we can remove, we can remove that. So we want to do the publish, but we want to do it without the restore. because we already have the restore in the step before. We want to target Alpine x64, and we want to run it as publish trimmed, so we get a smaller file. We want to publish as ready to run, and we want to publish as a single file to make it even smaller. Publish single file equals true. Oh no, that was the wrong one. What I wanted was to enable the word wrap. Okay, now we see everything. So this is the publish step that we want to have in place. We have a single file. Oh, and we need to have it as a self-contained as well. Okay, I hope I don't have a typo, but let's see in a second. Now this is basically the build step where we create our application in the ideal way with all those parameters to make sure that we get a very small and self-contained binary that doesn't have other dependencies that we can immediately use. Now we have as a second step, or as a second stage to be exact, the runtime image. So this is again Microsoft.NET, but as I said, we want to have the one that only has the dependencies. And again, we're taking the Alpine based one and call it final or whatever you wanna call it. Then we expose port 5000. We add in the configuration. We create an app folder. We copy from the build stage. So from our first stage where we have done the build, everything that we have in app publish, which actually only should be one file because we have it as self-contained, and that also means that we no longer will run .NET, but we will just run our binary. Okay, so just a quick recap. We have our first build stage. That one has the SDK image. We do an optimized restore. We do an optimized publish and put it into the app publish folder in our build stage. Then we have the final stage, which only has the optimized runtime image. And then we copy from the build stage there from the app publish folder into our app folder. And then in the end, we run the generated self-contained single file. Let's see if that has worked. We run the Docker build again. And no, it hasn't. Oh, I have a typo. Alpine. Let's try again. Okay, this looks better. Now, because this is creating the optimized binary, this is going to take around 70-80 seconds. At least that's what it has previously taken in my previous tests. So I want to take the next step in the presentation, and then we take a look at the results when this is done. The interesting question that we have when we are creating this build, and that's kind of a small optimization, is that we want to define what goes into the build context. To give you a bit of an idea of what this does is that when we run a Docker build, then it's providing all the files that it needs for that file into the Docker environment so that it then can create the actual build. And to make sure that we only have the minimum amount of necessary files in there so that caching can work ideally, it is as quick as possible, we're using as little memory as possible. We have a Docker ignore file, and that Docker ignore file works very similarly to the git ignore that you probably know. Syntax sometimes can be slightly different, but the concept basically is the same. You define the things that you don't want to have in your build context in the Docker ignore. I typically let Visual Studio Code generate it because it's very good at it, but let's quickly take a look at that one. So we have the Docker ignore here, and you can see that it excludes a lot of files that are in here and make sure that we're only pushing the minimum amount of files into the context. As you can see here, that's 35 bytes over here. And then later we have 442 bytes, so really, yeah, absolutely minimal. Okay, but now we have our optimized image, the myimage003. Let's see if we can still run that. That looks good. Maybe you've noticed that it is also starting a bit faster and it still works. So that's good. Let's run our vulnerability scan again. That one should also be a bit faster because it has gotten smaller. As you can see now, okay, we still have our issue, so we still need to fix that. But if we take a look at the size, you can see here, now we are really drastically smaller. Not even 80 megabytes, so this I would say is an acceptable size, given the fact that we have basically ASP.NET Core application, which just brings a bit of baggage with it. To also show you the impact of the Docker ignore file that we just took a look at, let's see if we, in the Dockerfile, assume that we have an additional expose, and then we run the Docker build again. Let's see what happens. You can see here that it has used everything from the cache, because the Dockerfile, based on the Docker ignore, as you can see here, is not put into the build context because we don't need it there. If I remove that part, save it, and run our Docker build again, you can see, and I'll stop it here, you can see that it is no longer in the place where it needs to copy over the files using the cache, because it now has the Docker file that has changed. If we put it in again and we run it once again, and you can see now we are again just using the cached files. So you can see that with the Dockerfile, we really have full control over what goes into the build context, and we want to make sure that this is the minimal amount of files, so we don't actually have any mistakes, we don't leak any secrets, we don't put in any files that we don't want in there. And as you can see here, it also helps with the cache mechanism, it helps with speed and so on. Let's go back in here and remove that as exposed because we really don't need that. Okay, another thing that is interesting and best practice is that a container should typically have a health status. We also define that in the Dockerfile, and it is a way how a container can let, for example, an orchestrator like Kubernetes or Docker Swarm or whatever know that the container is still healthy. And if the container is no longer healthy because the application has crashed or we run into an unexpected error or whatever, then the orchestrator can recognize that something is wrong and can replace that container. Let's take a look how we can make that happen. In our case, the easiest way is that we just do a health check. And I'll copy that one in so I don't mistype. So you can see here, what we want to do is we want to just run a request against weather forecast. If we get something, then it's fine. If not, then we return an error. Now you might see that we're using curl, and curl is not in the Alpine base image. So as an additional step, before we can use that, we will run an add curl so that we have curl installed. And now this is also the moment when we want to fix our vulnerability, and that's basically the same place. So we just upgrade the library that we've seen that causes the error. Let's see what that means for us. Run the Docker build again, and we're done. Let's run the image or run the container. See if it still works. Yes, it does. Take a look at the vulnerabilities. Again, we are quite small, so that this should be fast. Yes, now we have updated the library that we've seen before here, and now we have no more vulnerabilities, so that is fine. If we now take a look at the image or at the running containers, you can see here that it says health starting, because it's trying to get the first health probe after 30 seconds by default. And now after 30 seconds, it has for the first time run that health check command. It has worked, and now we have the healthy state as expected, so we can let whoever is orchestrating the containers know that the application is still healthy. The only drawback to that is that we have now gone slightly bigger because we have added an additional updated library and we have added curl. But yeah, we want to have it for the health check and we want to make sure that we fix the vulnerability. So I think that is worth a bit of an additional size. Let's get back and take a look at the second to last thing, I think, which is the behavior of containers. And with that, I mean the configuration mechanisms that we have in .NET. They can also be used immediately in our containers. And as an example, I want to show two things, which is ASP.NET Core environment, and we want to push it in as an environment variable. So let's take a look what that means. So if we, where are we here, Visual Studio Code? If we just keep as is, and we don't change anything in the image, we still have the opportunity to pass in an environment variable. And now if we pass in the ASP.NET Core environment equals development, then we will get a different behavior. So if we go back in here, and you remember we didn't have Swagger, but now because we're running this in the development mode by the ASP.NET Core environment variable, we see that we have Swagger again. The reason for that is if we take a look into the startup, it looks at the environment, and if it is development, which we can trigger with that environment variable, then it adds Swagger in the Swagger UI. So this way we can use the familiar configuration mechanisms, we can use the different app settings files, we can use the environments. All of that works immediately just by setting the right environment variables. So nothing special to do for a .NET developer. You just need to make sure that you pass in the right variables when you start your application. Okay, let's take a look in here, and this one I think is the last one. You want to make sure that we're not running as a root user on Linux, because obviously if you're root, then you have a lot of you basically have all the permissions that you could have. So if there is a vulnerability in your application, if someone manages to go through a flaw in your application and goes into the container, then they would have root access to that container, and that's typically not what you want. So as a resolution for that, we want to create a dedicated user even without a password, give it access to the directory that we need for running the application, and that way we are not running with root, but we're running with a non-privileged user, and the process for our application is running with a non-privileged user. To just give you a quick idea, if you're doing the same thing under Windows, then you could use what is called a group managed service account. So then you could also have an Azure AD or an AD application user that has the permissions of that particular application. So you can use Active Directory permissions in that scenario. But it also has the container administrator and the container user, which is basically the equivalent of root and non-root on Linux. So you can do the same things in a Windows image as well. So let's go back into our application, into the Dockerfile, and now we have the commands here. Those still require root, so we shouldn't do that before, but afterwards we can do the change of the user. So we run an add user without a password. The home folder is app. We trigger the password file. We have that one as non-root, and we give that user full permissions to the app folder. And then we let Docker know that from now on we want to run with the non-root user, and with that we are fine. To just give you an idea of what it looks like before we have run the application, let's first take a look in here. So this is our old container that is still supposed to run as root. If we get a terminal inside of that particular container, we run a who am I, you can see it's root, and you can see that our application also is running in the context of root. So yeah, this is our old version, not yet optimized. So let's optimize it, create the build, version 5, that looks good, run it, and we are up and running. Let's first see if it still works. Yes, that works. And if we now take a look again, wrong one. Now we are the non-root user, and the application also is running in the context of the non-root user. So we have avoided to run our application as a root user. Oh, and yeah, let's also, just to make sure, again take a look at the vulnerabilities. Still a small image, so we get a result very fast. Still no vulnerabilities. And if we take a look at the size, you can see here that this is exactly the same as for the previous version, because we have just added that directive in the Dockerfile, and that doesn't really add an overhead. So really it should be a no-brainer to move to non-root users in your environment if you can. Okay, we have seen the demo, and that's it from my side. I hope I could help you to get a quick start on the best practices, on the important steps that you have when creating your production-ready .NET Docker images. With that, I want to say thank you for your attention. And again, those are the handles, the URLs, and so on if you want to reach me and have a nice conversation around containers, Docker, and whatever you want to come up with as technology topics. Thanks, and have a lot of fun in the further all hands.